Thank you. All right, so welcome to the first actual training session. We've had some great presentations. Lou's keynote was amazing. Get to see all the great stuff we've been working on. And we appreciated Tommy's presentation from TrueCar as well. I thought it was interesting listening to him talk about the fact that great customer experience really starts with the foundation, with the processes of developing and deploying software, and also making sure that your server-side code is rock solid, right? That it's performing as well as it can. But what's interesting, it was to me, is if you think about a web-based application, for example, where your browser pages are taking, let's say, 8 seconds to load on average, that out of those 8 seconds, how much time is actually spent on the back end? Maybe 2, 1.5, right? It's just a fraction of the total time. So as important as it is to make sure that your back-end code is optimized, then you need to come out to the client side and say, well, what's happening on the mobile device, or as we're going to talk about today, the browser? How can I monitor the performance of those page loads in the end user's browser? And then if there's a problem, how can I diagnose and correct that problem? So that's what these sessions are about. Usually I would do 2 hours and integrate the lab with the training, but to break things up, because of the way the time worked, I'm going to talk for 45 minutes, or hopefully less because we're running late. Then we'll have lunch, and then you're welcome. You're encouraged to come back after lunch, and I've got a sample application that's having a problem, so you'll get to log into that and try to figure out what's wrong with it based on what I'm about to tell you. So here's our agenda. We're going to try to cover 2 products in, well, when is lunch? I don't even know what our time is, but anyway, between now and whenever the food gets here, we'll talk about browsers. So we'll start off talking about how browser works, how to add it to your application, what is it actually measuring? And then I have a sample app different from the one that you'll get to troubleshoot after lunch that I'll use to demonstrate the process of troubleshooting a performance problem. With the time that I have, which won't be much, I'll try to touch on some of the other browser features that aren't specifically devoted to troubleshooting. Things like filterable geography, the browsers tab that tells you what browsers your customers are using, the pages tab that shows which pages of the site are generating the most traffic. If I don't have time for that, we do have a lot of great online training material on our website, learn.newrelic.com, that covers these features. And then again, I probably won't have much time to talk about alerting, but we heard about alerts this morning with that new dynamic baselining feature. And so you can configure alerts based on browser metrics, things like page load times, JavaScript error rates, etc. And one of our marketing people is fond of saying, if you're not alerting, then you're not really monitoring, right? Then you're just reacting to problems rather than proactively handling them. And on the subject of proactivity, we're going to talk about our other product, Relic Synthetics, which does not measure performance on your end user's machine, but it's actually under your control. So you decide what to monitor and where to monitor from and how often to check. And then you can be proactively notified, hopefully before your customers notice that there's a problem. You can get a ping and say, hey, your site is down, or it's slow, or it's experiencing errors. And then we'll talk about the process of creating the various types of synthetic monitors. I have a session this afternoon that will go into more detail about synthetics scripting. So you can actually write a script to automate a browser. And we've got a whole other session, I think at 3:15 this afternoon, that'll talk about that. And then once that monitor's been running and gathering data about your applications, we'll show you how to view and interpret those results. I did also want to mention, let me bring up the URL, that we have a Slack channel, and you're invited to join that. I posted it in the little FutureStack app, so you may have seen a little notification about that. But here's the URL, https tinyurl, or URL, who says URL? URL, okay, one URL, and okay. tinyurl.com/nru-sign-up. Okay, so there's the URL. If you'd like to go there, you enter your email and it will invite you to our NRU, New Relic University Slack channel, and there's a #FS16, a FutureStack16 channel in there. That you can gossip about me without me seeing. I have an assistant up here who's going to monitor that channel, and he'll answer questions or repeat them to the room so that I can answer them. So you're invited to do that. But if you don't want to do that, you just raise your hand, and we'll have time for Q&A. oh, shall I show that again before I delete this? Okay, tinyurl.com/nru-signup. Okay. All right, let's get to the content. Here we go. So many of you are probably familiar with sort of our flagship product, our first product, New Relic APM, which is designed to monitor your back-end code, your Ruby code, your Java code, your .NET, your PHP. So that works by deploying a language-specific agent on your application server, and that agent goes in and injects instrumentation into your code to tell you how's your app doing on the back end. Well, for browser, that language, that server-side language agent can automatically inject a little snippet of JavaScript into each web page that gets sent down to your end user's machine. And I'll talk in a minute. We encourage you to allow that to happen automatically, but if for whatever reason you don't want to do that or you can't do that, there's an alternative that I'll talk about in a minute. So that little JavaScript goes down with the page to the end user's machine. And it turns out, something I learned after I started working at New Relic, that browsers, most of them, are already measuring how long pages take to load. There's an API called the Resource Timing API that browsers like Chrome and Firefox and Safari, all the modern browsers, even IE has it, amazingly, measures how long each resource takes. So the HTML sort of skeleton of the page, and then every CSS file and JavaScript file and image that comes down, it measures how long those resources take to download. AJAX calls, if the page is making calls out to services, how long do those take? So our little snippet of JavaScript, if the browser supports the Resource Timing API, we're just querying the browser and saying, hey, Chrome, that page that just loaded, how long did it take? And how long did you take to parse the HTML? And how long to pull down this image in that JavaScript file? If you're on a browser, or if the user is on a browser that doesn't support the Resource Timing API, something like maybe an Android mobile device, then our little JavaScript will do its best to try to figure out that metric information. But obviously it'll be richer if we can get it directly from the browser. And then once per minute, the little JavaScript agent on the end user's machine will send up to our collector in the cloud the gathered metric information about that page, which you can then see when you log into your account. So I'm going to switch over to an account. So we use New Relic to monitor New Relic, and this is some actual browser data from the New Relic blog, blog.newrelic.com, which I believe is a WordPress application. And you can see that over the last 3 days, our average page load time that you can see up here, here's the average, is about 9.5 seconds, 9.67. But we've had a few little spikes there. Here's a 15-second average and 14, 15. So we've had some spikes where things are not as fast as maybe we would like them to be. So this is the kind of information that browser is reporting from the end user's machine. And let's talk about what we see here. We see some pretty colors. What are they telling us? So if you've used APM, you may know that APM is measuring back-end performance sort of by the phase or the, I'm trying to think of the right way. We separate the timing of the application into the different elements of the app, the code, the database time, the external service time, the network processing time, etc. So we've tried to do something similar on the browser side. We break the page load time down into these components, and you can see the colors here. There's dark brown for network, sort of light tan for what we call DOM processing, blue for page rendering, and if the back-end code were being monitored, which for this app it is not, you might see some purple there that says web application. So that's the time that was spent executing code on the server. So what exactly do these colors refer to? I'll tell you. If I can get this diagram to show up. Oh, synthetics, I went too far, come back. There it is. So if you think about the life cycle of a browser page request, it begins with the user either clicking on a link or entering a URL in the address bar, and that's when we start the clock, when the user says, give me this page. And you can see that number one on the far left is when we start the timing. The first event that happens is the browser sends a request to the web server. So that dark brown segment on the left is network time sending the request. Then the web server usually has some work to do. So any time that's spent on the back end will show up in purple, and if it's an APM monitored application, you'll get more detail about that purple time, right? If it's a Rails app running on the back end or a .NET app or Java, we're measuring that time in APM, and we'll show that in purple on the chart. After the server is done doing whatever work it needs to do, then it sends a response back to the browser. So that's more network time, right? There's a request and a response. Now on this timeline, we've separated those into separate elements, but on our chart, we munge those together. So the dark brown indicates the combined network time sending and receiving data, sending to and receiving from the web server. Once the data comes back from the server, the browser gets its first byte of HTML, and that's when we start the DOM processing phase, that light tan color. And now we're segmenting these times based on events that are fired by the browser. So the DOM content loading event, I believe, is the one that triggers the beginning of DOM processing. That is downloading the HTML for the page, finding resources that are referenced in that HTML that might change the structure of the DOM, the document object model. So what could that be? What might change the structure of your page? Well, it could be CSS files that are changing attributes of elements on the page. It could be images that are referenced in the CSS that have to be fetched. It could be JavaScript in the head section of your page that's changing the structure. So this is oversimplifying. Shane is probably going to correct me on this, but I like to think of DOM processing as the head section of the page. When you look at your HTML source, whatever's in the head is pretty much what's happening during DOM processing. When that's done, the browser will fire a DOM content loaded event, or this says DOM content ready, but I've only seen loaded. That means, all right, the browser has fetched all of the HTML and parsed it and constructed an in-memory representation of the page. Now it's ready to actually display it on the user's screen, which we call page rendering. And I like to think of that as the body section of the page. So any resources that are referenced in the body, like images, AJAX calls that get made from the page, etc., those are all timed during page rendering until the end of the window load event. So when the browser is done, it's going to fire a window load event. You can put JavaScript code in that event. The time that it takes to execute that code is also included in the page rendering time. And finally, at the end of the window load is when we stop the timer and we say, okay, the page is fully loaded. Any questions about that so far? Does that make sense? Okay, good. So when you're looking at a chart in New Relic Browser, if you're not happy with your page load time, then step one or question one is, well, during which phase of page rendering is most of the time being spent? This one's kind of hard to call. It's a pretty even split, it looks like, on average. During the spikes, which are daytime, it looks like, when during business hours in the United States, it looks like when our log gets most of its traffic and slows down. It looks like during those times, the DOM processing, the light brown section might be a little bit bigger. And then when the DOM processing calms down a little bit, then maybe page rendering picks up. But we're going to drill into those and see where we can get more detail and figure out exactly what's happening. So step one, during which phase of page rendering is time being spent? Then step two is, well, we want to dig into those and say, all right, well, if I'm spending 6 seconds, as it looks like here, in DOM processing, what's going on there that's taking so long? So I want to be able to dig into this segment and figure out exactly what's happening. And if I scroll down on this overview dashboard, I see another feature called session traces. So session traces are, unlike the chart that we see above, which is average or aggregate data. When I point at this one data point, trying not to step off the edge of the stage here, this one data point you can see in the box up there is referring to 30 minutes, it looks like, a 30-minute average period of time from 1:23 a.m. to 1:53 a.m. If I were to zoom in, I'm looking at a 3-day time window up here. If I were to zoom into 30 minutes, a 30-minute time window, then each data point on the chart would be 30 second, what am I trying to say? 1 minute of time, sorry. If I'm looking at a 30-minute time window, each data point is 1 minute of time. But as we zoom out into a longer time window, we're looking at bigger chunks. So this is aggregate data. But if I want to see what's going on during a specific page load, then session traces allow me to see that. These are not average or aggregate data. These are individual sessions at 11:52 a.m., which was how long ago? Just a few seconds, a couple minutes ago, 4 minutes ago. Somebody viewed a blog post about Seymour, which we just heard about this morning. The page took 5 seconds to load, and I can click into that session trace. And it gives me the breakdown of how long each of those phases took. And one point I want to make is that these times up here, 2.5 seconds, 5.05 seconds, are cumulative times, not discrete. In other words, page rendering did not take 5.05 seconds just for that phase, but rather these are points along a timeline. So we spent 0.5 seconds on the server doing whatever back-end processing needed to happen. Then we spent about 2 seconds doing DOM processing. 2 plus the original 0.5 took us to 2.5 seconds into the session. And then from there, it took 2.5 more seconds to actually render the page on the screen. So these are like time stamps along a timeline, and you can kind of see that up here. Can I zoom in and make that a little bigger? So you see the little purple section above my Mickey Mouse glove is about 0.5 seconds. That's the purple. And then at 0.5, the color changes over to the gold or the tan for DOM processing. And from there over to 2.5, that's my DOM processing phase. And then from 2.5 to 5 seconds is page rendering. So that's what these time stamps are referring to. And then I've kind of already shown you, given away my surprise, that as you scroll down, you can see each individual browser event that fired during that portion of the page load. So that the purple color is my server side. Again, this app is not monitored by APM, so we're not getting information about the back-end code, but we can still see all of the sort of network housekeeping that the browser needs to do. The navigation start is when the user requested the page. The browser said, okay, I'm going to start the fetch event. I'm going to start the domain lookup. I'm going to connect to the server. This is probably not an HTTPS, a secure site, but if it were, there might be some time spent negotiating that SSL encryption. And then once the server is done doing whatever it needs to do, then this DOM loading event says, all right, we're going to change color now. We're done on the server, and now the browser is fetching the resources to build the in-memory representation of the page. So here, not only do we get a row for each resource, but the horizontal length of each row tells you the relative amount of time it took to download that resource. And you can hover over each one to see details. So here's styleguide.css. The full URL is there, WP content themes, blah, 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 style guide. Took about 500 milliseconds to load. And I got some really long ones here. This looks like a video. It's an SVG. So there's some animation, the animated New Relic logo, it looks like. And those are scrolling off the right side of my screen. So maybe I want to zoom out a little bit using the minus sign so that they all fit. For some reason, this headshot of Henry Shapiro took 1.5 seconds. He's slow with everything. No, I'm just kidding. So that's like a really long, slow-loading JPEG for some reason. But this is telling you, so if you're concerned that your DOM processing phase is taking a long time, you can come in and look at an example of a page load and say, well, which resources are being processed during DOM processing and which ones are taking the longest amount of time? Just at sort of spitballing, if I were to try to improve this performance, I would say, look at this. This is an awful lot of round trips that we're having to make. Each one of these rows is the browser sending a request to a server and saying, okay, get me this CSS, get me this JavaScript, get me this JPEG, get me, right? So that's a lot of requests. And so if DOM processing is taking longer than you would like, if the number of resources is high, you might want to reduce those. On the other hand, if the horizontal length of the bars, if the amount of time it takes to download them is high, then you can look at things like compression, caching, content delivery to try to shrink the amount of time that it takes to download each resource. Okay, so that's what's happening during the DOM processing phase. And again, I think most of these resources are in the head section of this page. Once the head or the DOM is built and that section is done being processed, then the color changes. You can see that fairly clearly. And we switch to the DOM content loaded, or DOM content is done being loaded, and we switch to the page rendering phase. So now what's happening is the page is rendered on the screen. We're fetching some additional resources. Some more, I'm not sure what kind of asset that is. Something from SwiftType. I would guess JavaScript, but it doesn't actually show me an asset name for that one. Some other interesting things are happening here. I don't know if you can see it. Let me zoom in if I can. Can you see that there's a little purple item there that says mousing over a div with an ID of promoted post? So we actually monitor, not in a creepy way, we can't see what the user is typing or anything like that, but we can see how they're interacting with the page. We will watch the browser session. This took 5 seconds to load, but at 3.7 seconds, the user started interacting with the page. And we continued to watch their session for a total of about 7.57 seconds over on the right. We'll actually watch it for up to 10 minutes until they either close the browser or navigate away from the page. So that can be really useful if you're troubleshooting a JavaScript error, kind of like the mobile interaction trail that we saw from Susie during the keynote this morning. This says, here's what the user was doing on the page leading up to that JavaScript error. So that's the kind of information that we're seeing in a session trace. And again, it's really useful if you're trying to break into the segments of the chart and say what exactly is going on during DOM processing or page rendering so that I can try to speed that up. Now, session traces are an interesting beast, especially if you're coming from the world of APM. APM has transaction traces. I'm trying to get back to my list here. Transaction traces in APM are details of back-end code, and we trace the slowest ones, the ones that take the longest amount of time. Session traces in browser don't care how long the page took to load. They're not triggered by the page loading slowly. Instead, they're just random samples of page loads, and they're being measured on the end user's machine, and that's an important distinction. Let's see if I can find, I'm gonna look at this popular programming languages page. So I jumped to that previous session trace right from the overview dashboard. I was on the overview, I looked at my chart, I scrolled down, and I grabbed a session trace from here. This little segment shows the 5 most recent session traces. So if you just want one, sort of at random, you can pick one. But there's also a session traces menu that shows more than 5. I think last time I counted there were 30. And it is filterable. So if I'm interested in a specific page, we had a blog article on the most popular programming languages of 2016. I can type popular. These are all the same article, all the same URL. And so I can see what session traces do I have for that one URL. Look at the range of page load times. Here's one that took 2.2 seconds. Here's one that took 128 seconds on Android. So I'm guessing they were on like an edge network connection. It was really slow. And then we've got everything in between. Here's 5 seconds, here's 16, here's 22. So how fast is this site, right? Is it 2 seconds? Is it 30 seconds? How long does the page take to load? Well, all of the above is the answer, because we're measuring on the end user's machine. That end user performance is affected by a lot of variables that we may have no control over. Like if this Android person is on a slow data connection, we can't do anything about that. If this, what else do we have? This 22-second one was on Windows Firefox. Why did it take 22 seconds? Who knows? They might have slow internet. They might have 27 browser tabs open. They might be playing BioShock in the background. We don't know what they're doing on their machine. So While browser data is valuable, it's telling you the experience that your users are actually happening, you do need to take these page load times with a grain of salt because they're highly variable based on, in many cases, due to circumstances that you have no control over. So in a few minutes, we're going to talk about synthetics, which allows you to monitor your page load times in a more controlled environment that helps remove some of that variability. Any questions about this sort of troubleshooting process, right? You start with the overview dashboard, you figure out during which segment of the page load is most of the time being spent, and then you can use session traces to drill down into that phase and see exactly which resources are taking the most time, or if there's a lot of them, right? I'm downloading lots of stuff, and all of those round trips to the server are taking a lot of time. Yes? The size? So the question is, if you're looking at that session trace and there's an asset that takes a long time to load, does it show the size of the asset? I don't think it does. I'll pick one of these. It shows you the start and end time and then the difference, the length of time that it took. But no, the size is not here. Now you can see it in a few places. You could go to Insights, right? You've got the URL there. This is 30514-300 by 300 JPEG. So I could go to Insights and say, how big is that? We capture, well, if it's a synthetic request, we're going to capture that as a Insight event. And also our synthetics tool itself. If I'm monitoring this page in synthetics, I'll show you in a minute, but we do show you all the detail about including the size of the element, but it's not visible in this particular view. Were there any questions in the chat window? Okay. Yes, sir. Sorry, I can't hear you. Oh, do you need to introduce any? So yeah, I kind of glossed over that. I mentioned it in the slide, but I didn't go into detail. So the question is, do you need to put any JavaScript code in order to get this data? So under app, well, I'll go back to the list of apps. How about that? I don't want to do this in staging. It's going to create noise, so I'll do it on my account. Okay, so when you log into your account, if you go to the Browser tab up top, it'll show you the list of browser applications that are reporting to your account. And then there's a link in the upper right here that says Add More. And this will walk you through the process of deploying New Relic Browser in your application. The short answer is yes, there does need to be some JavaScript code, but you don't necessarily need to add it yourself. So when you come here, it says, question 1, how do you want to deploy the JavaScript agent for New Relic Browser? And what we recommend is to, if you're using APM on the back end, just let the language agent for APM inject that JavaScript for you. So if you're monitoring a Rails app or a PHP or Node or something on the back end, well, Node doesn't do it, .NET or these other languages, can automatically inject the JavaScript into the page for you. So you can choose your instrumentation or your deployment method. Then you can say, what kind of data do you want? If you're not paying us for browser, we have a light version that doesn't give you session traces, but it does show the page load timing and sort of high-level information about which pages your users are visiting the most often. If you subscribe to browser, then our pro level allows you to see session traces, JavaScript errors, AJAX calls, things of that nature. And then we just recently rolled out a new set of features for single-page apps. And I'll show you what that looks like in a second. So if you go to Pro plus SPA, then we'll give you the JavaScript agent that doesn't just measure the full page load from the server, but it will also track every time something like Angular or React or any kind of JavaScript on the client says, the user clicked on a link, I need to go fetch some data from the server and render it on the page. It's not a complete HTTP or HTML round trip to the server. I'm just getting a blob of data and rendering it in place. We call that a route change or a route change. So the SPA support measures those, which route changes are taking the most time. Now, what if you can't or you don't want to allow APM to deploy the code automatically? Maybe you don't have access to the server side, your developers are cruel and they won't let you do that. Or you don't want to monitor all the pages, you just want to put this JavaScript on certain pages, you have the option of manually copying and pasting the JavaScript code. So you can select option 2 there, and then choose what type of agent do you want, Light, Pro, or SPA. If you're monitoring the app with APM, you can choose yes here, and the JavaScript that gets generated will link the little snippet of JavaScript to your APM application. If you're not monitoring with APM, then you can say no, and you just give it a name, my FutureStack application, and say enable. And then we generate this little blob of JavaScript, and you can paste that in your page as close to the top of the head section as possible. So there does need to be a little bit of JavaScript. It's pretty small, but you can either put it there manually or let our APM agent inject it for you. Way in the back, you're gonna have to speak up, or maybe Tori can translate for you. Yes, sir. Sorry. Sorry, what's the question? Oh, the overhead, thank you. What's the overhead? Do you know the answer to that? It's hard to say, right? Because it's gonna vary. Shane is one of our support engineers, so he answers this question a lot. Yeah, it does a post to, we've got an API endpoint, and the JavaScript agent will post its collected data once per minute. And again, you can actually see those posts in the session trace, and they're very small payloads, but it is doing a little AJAX call about once per minute. Okay, is this countdown accurate? Do I have 12 minutes left? Is that what it's telling me? Okay, well then we need to talk about synthetics. So I'm gonna change the topic, but I will mention, let me talk quickly about Sba support. So what we've been looking at with that blog example was what we call the page view load time, that's measuring how long the page takes to load, DOM processing, page rendering, etc. If you have a single page app that's doing route changes rather than a complete round trip to the server, you can toggle this little chart and say, well, show me the SPA load time. And so the initial page load is the blue line. That's how long it took to pull down the page the first time. And then your average route change time is shown in yellow. So this is a simulated food ordering app. And as users click on a restaurant, we download the menu and we show you the list of menu items. And so those calls are averaging about 0.3 seconds. And then on the page views menu, we will show you both the initial page load and the route changes, and these are filterable. So right now we're grouping by browser interaction name, which is essentially the URL on the left-hand side. And then I can say, well, I want to see only initial page load. So I've added a filter up here, and it shows me just for page loads, here are my 3 most time-consuming pages. Or I could say, show me just the route changes. Okay, so now which route changes are taking the most time, etc. Now, if I go back to my other app, which it's not using SPA, in that case, the page views menu just shows full page loads. And this can be useful to help you figure out if I need to troubleshoot or if I need to optimize my site, which pages or which code paths should I focus on first. So this is a blog. It's a WordPress blog. If you think about the structure of a URL of a blog, it's blog.newrelic.com/year/month/day/title, right? I could show you one, but take my word for it. So I don't particularly care if one article or one day is slower than another day, because it's all the same server-side code, fetching the article from the database and rendering it to HTML. So we will automatically try to aggregate the URLs that are executing the same code on the back end. Viewing a blog article is that first item. It's taking 95% of my total time, which makes sense because it's a blog. And so we roll up all of those URLs into an aggregate to say the code to display a blog article is taking this long. But sometimes our customers wish that we wouldn't be so aggressive with the aggregating. They'd like to be able to see some more detail about a particular type of element. For example, the categories of our blog. Notice that these are, author is blog.newrelic.com author/*. The author info page for any author is rolled up into that element. But the categories are not all rolled up. We've got each individual category broken out. New Relic News, New Relic Products, Tech Topics, etc. Why are those broken out, but author is all rolled up? It's because of this little known feature called segment whitelists. So if you come to segment whitelists under settings, you can actually specify for a given domain segments of URL that you would like to track separately. So we've added the string category as a whitelist segment, and any URL that has category between the slashes is now going to get tracked separately rather than rolled up into a big aggregate. So if you're looking at your list of pages and you're saying, oh, it's rolling everything up with an asterisk and I'd like to be able to see some more detail, check our documentation on segment whitelists and we'd tell you how to set that up. Okay, so there's a lot more about browser that we don't have time to get into. I'm going to refer you to learn.newrelic.com, which is our New Relic University site. And under self-guided courses, Intro to Browser, we've got 32 minutes of video that you can watch about browser, about all of the other features that I don't have time to talk about today. But for my last 7 minutes, I'm going to talk about synthetics. So we mentioned already the fact that, let me go back, that we're measuring time on the end user's machine, and so we can end up with those widely varying page load times, where the same URL can take 2 seconds or it can take 100 seconds. So what can we do about that? Well, New Relic Synthetics, rather than measuring page loads on the end user's machine, I won't show you there. It measures it in a controlled environment. So in Synthetics, you can set up a monitor that either measures a single URL or actually executes a script to automate a browser. And it's running, I'll set one up and show you what's involved. Hello, Jim. I'm going to close that. So to set up a new monitor, you say Add New. And currently we have 4 types of monitors. The ping monitor is, we don't charge you for it, so you don't have to give us any more money to use a ping. That's essentially site availability. You can have 50 of them, right, for free. So you can monitor up to 50 URLs. Just hit the server, make sure that it answers. You can optionally check for a string in the response to make sure that the data that's coming back is correct. So that's just very simple availability monitoring, can alert you if your web server goes down. The other monitor types do require a subscription. The simple browser spins up an actual instance of Google Chrome, visits the URL that you specify, loads the full page, including all of the resources on the page, and then I'll show you in a minute, it actually gives you detail about what took time on the page. It looks very similar to the session trace that we see in browsers, so you can see which resources are taking the most time and the size. Whoever asked about that, you can see how big those are as well. Scripted browser goes a step further, spins up an instance of Chrome, but now instead of just visiting a single URL, you've now got a whole Node.js development environment where you can import modules and automate the browser to do exactly what you would like. So that's valuable for simulating user behavior. If you've got a site like TrueCar, for example, where you want to log in, browse some dealers, pick a dealer, fill out the form where he said that form was broken and if it didn't work, they made no money, they'd probably want to write a script that goes through that user flow and says, let's fill out that form and make sure that it's working and alert me right away if it doesn't. So as I mentioned, I've got a session at 3:15 this afternoon that you'll get a chance to practice writing a scripted browser monitor. And then if you provide API endpoints or if you rely on API endpoints and you want to make sure those are up and running and performing well, you can create an API test monitor, which is also a script, but instead of spinning up a whole browser, it uses an HTTP client object to exercise the target API. So once you choose the type of monitor that you want, then you can select from where do you want this monitor to run. Currently, I believe we have 14 locations around the world, unless that's changed recently. We also support a feature called private locations up here for a nominal extra charge. We will actually give you our little virtual appliance that you can run wherever you wish, behind your firewall or in your own data center, and run our same monitoring code or monitoring, we call it a minion, our little agent, but you can get to sites that maybe our public ones can't get to, or if you wanted to monitor from someplace in the world where we don't currently offer that option. And then number 4, how often would you like to visit your site? As frequently as 1 minute, or as infrequently as once a day, or these various options in between. So we can hit your site every 5 minutes or 30 minutes, etc. We try to spread these out. That's what this little text says on the screen. So if I were to pick 5 locations, Atlanta, Portland, Tokyo, Sydney, Dublin. Is that 5? Okay. 5 locations, and then I say every 15 minutes, it will space them out roughly about every 3 minutes. So we're not going to hit all 5 at the beginning of the 15 and then have 15 minutes of dead time. It's not exact, but we try to spread them out within that time. And then you can see, this is how we charge. When you subscribe to Synthetics, you buy a bucket of monthly checks. And if you multiply monitor times locations times frequency, it will deduct from those monthly checks. And I'm currently quite over my limit. But since I work there, they let me get away with it. But in real life, you'd have a sales rep calling you saying, we noticed you're using more than you've paid for, so either turn some off or give us more money. And then the last option as you're setting this up is how shall we contact you if this monitor fails? You can very simply, if you say email me, we'll do all the background work to set up an alert policy. So you give us your email address and what you want that policy to be called, and on the back end, we're going to create a policy in our alerts system with an email notification channel that's monitoring this synthetic job, and we'll contact you if it fails. If you already have alert policies, you can add this Synthetics monitor to one of your existing policies. And then the third option is, that's okay, you don't have to notify me, I'll come in and check. Oh, here it's telling me I'm 4,510 over my limit. So what do you get? I got a minute and a half to show you. Once you've got this monitor running, it's going to show you information like this. So here's a site I'm monitoring from 10 locations. I can't count that quick. 4, yeah, it looks like 10. And it looks like they're all kind of bunched up around the 15-second mark. So if you're having a situation like we saw with the blog, where some pages take 2 minutes and some pages take 30 minutes, you can set up a monitor in Synthetics that says, just hit my home page or my blog site or whatever it is that you want to monitor. And this now is a dedicated machine that's not doing any other work. It's only running browser. It's got a fast internet connection because it's in one of these cloud data centers that we use. And you control what the browser does. So you're not limited to the end user deciding to take a particular code path or to visit a certain page. If there's things you really care about, you can proactively monitor those in Synthetics. And then during our lab after lunch, we'll look at this. We'll say, here's my app that browser says is taking X amount of time. How can I use Synthetics to sort of sanity check that and say, well, is it 30 seconds or is it 2 seconds? What is it? Synthetics will help us to answer that question. If you look at an individual result of a monitor, Here's one from London a minute ago that took 16.4 seconds. Again, we give you that view that looks kind of similar to a session trace, where we've got each individual resource that was requested on the left. You can see the relative length of time that it took to download the resource. The color indicates the type. So blue is HTML, pink is JavaScript, green is image, etc. And then you can drill down and look at a particular one. So for this image that took 3.1 seconds to download, I can see a breakdown of the total load time. It looks like DNS is why it took 3.1 seconds. So right, I don't have to worry about my network time or my web server, but I might want to figure out why is it taking so long to resolve the URL. And then it does tell me the size, 8.04 kilobytes, and I can see the request and the response headers if there's a problem to try to figure out exactly what's going on. Okay, I'm now officially out of time. I did want to mention that we do add an X-abuse info header, so you can't do a DNS. You can't use synthetics to spam somebody else's site. They're going to know that it's our fault. But what it might be interesting, there was an interesting blog article on our site early in the presidential campaign that said, let's compare the performance of the presidential candidates' campaign websites and see which ones are performing the best. So we were monitoring sites that we had no business monitoring. They weren't ours, in other words. We were monitoring sites that belonged to somebody else. So you might be interested in that. Do you have a competitor? Do you want to know how their site is performing compared to yours? You can do that, because it's just spinning up a browser and sending requests. So don't go overboard and try to bring them down. But if you just want to sort of visit once in a while and say, how's my #1 competitor's site doing? You can do that. Okay, so I'm going to wrap up now because we're out of time. But if you're interested, come back after lunch at whatever time that'll be. It's supposed to be 1:15, but we're now in an alternate reality. And we'll actually practice troubleshooting some browser sites that have issues. Thanks.
Thanks, Phil. Big round of applause for Phil, please.